Hello, Algebra 2 students. My name is Mrs. Hart. I am your substitute teacher for the day. Mr. Clive is not here because he's on vacation, but I'll be teaching you about exponential functions and equations, and logarithmic functions and equations. The first thing we're going to discuss is graphing exponential functions. To graph exponential functions, you're going to have to use graphing software. You cannot simply do it by hand. Graphing software such as GeoGebra, as I have on my computer, can be used to graph exponential functions, or you may use a graphing calculator. For example, say you have the function f of x equals 5 to the power x plus 5. To graph this on GeoGebra, you're going to enter f of x in the input bar at the bottom of the screen equals 5, and after you add 5, so that the computer knows it's an exponent, add the to the power sign, like this, and then enter the parentheses around the exponent, x plus 5. Make sure the parentheses are around the entire exponent, or this function will not be correctly graphed. Once you have typed all that into the input bar, press enter, and this will be the function that is graphed. As you can see right here, it looks like the line looks like the graph touches the line y equals 0, but it really does not. Y equals 0 is a horizontal asymptote of the function. An asymptote of the function is a line that the graph comes close to, but never actually touches. Even though it looks like it, it simply gets closer and closer to the line and never touches it. One more thing about this exponential function, as you see that 5 is added to x on the exponent, this means that the graph of this function moves 5 to the left of the graph f of x equals 5 to the power x. Now, let's talk about graphing logarithmic functions. Get to my eraser here. Logarithmic functions are simply the inverse of exponential functions. So let's say if you want to graph a logarithmic function, you're going to have to use graphing software just like you did for exponential functions, such as GeoGebra, as I have it right here. Let's, for example, say you have a logarithmic function f of x equals log 5 plus 7. To graph this on GeoGebra, you're going to type f of x equals log, but do not write log, just write lg, and then put the argument, which is 5, in parentheses, and then add plus 7. Once you have typed that, the function will be graphed. You press enter and it will be graphed. And this is the function, the logarithmic function. As you can see, there is also a vertical asymptote, just like there was a horizontal asymptote in the exponential function. It is a vertical asymptote at x equals 7. The line may look like it touches x equals 7, but it does not. Simply comes closer and closer. That means that it is a vertical asymptote of this logarithmic function. Now, let's move away from graphs for a little while and just talk about logarithmic and exponential equations, how to solve them. Say you want to solve the exponential equation that is 7 to the power x plus 7, x plus 7 is the exponent, equals 2,401. The way to solve this, you want to make the bases of both sides, this is the base of this side, and this is the base of this side. You want to make them equal, otherwise you will not be able to solve this. To make them equal, you have to see if 2,401 can somehow be turned into a base of 7 with an exponent. It turns out that 2,401 is 7 to the 4th power. So, replace 2,401 with 7 to the 4th power, which is the same as 2,401. Now, the bases, both 7, are equal. You can eliminate the bases and are left with the exponents. X plus 7 equals 4. This is much easier to solve than what it looked like before, and you simply solve it by subtracting 7 from both sides and are left with the answer x equals -3. If you would like to check your solution, substitute x equals -3 for x in the original equation, and as you see, 7 to the power -3 plus 7 equals 7 to the 4th power. Simplify the exponent, 7, and add these exponents together, -3 and 7, and you have the exponent 4 equals 7 to the 4th power. Both the bases and the exponents are equal, so this confirms the solution. Now, on to logarithmic equations. Logarithmic equations. Say you have the logarithmic equation, let's see, log 13. Not 13, let's replace 13 with 12. Log 12 minus log 6 equals log x. These are the arguments of each logarithm. Each of these logarithms have the base of 10. You may not see it, but when a logarithm has the base of 10, it is simply taken as the common logarithm, and the base of 10 is not written. So each of these logarithms have the same base. As you will learn soon in properties of logarithms, when one logarithm is subtracted from another, you divide the arguments. So you're going to divide 12 by 6. 12 divided by 6 equals 2. So you have log 2 equals log x. The equality property of logarithms states that when the bases of logarithms are equal, and they're both 10, even though they're not written, they're both the common logarithm, the arguments are equal. So since the bases are the same, you can just eliminate the logarithms, and you are left with 2 equals x, the solution. If you feel like you need to check and make sure this solution is correct, you can substitute 2 for x in the original equation. Log 12 minus log 6 equals log 2. Simply do what you did before. Divide 12 by 6, since log 6 is being subtracted from log 12. Divide 12 by 6, and you have log 2 equals log 2. They're equal, so the solution is confirmed. The last thing we will talk about is the properties of logarithms. We'll discuss 3 of them: the product property, the quotient property, and the power property. First, let's talk about the product property. The product property states that when 2 logarithms are added, multiply the arguments. So let's say I have two logarithms equal to another logarithm of argument x. They're all the common logarithm. So the first logarithm has an argument of 9. That's not a t, that is a plus sign. Log 9 plus log 8 equals log x. To solve this, they're being added, so you use the product property. You multiply the arguments. Before you do anything, make sure the bases are equal. All the bases are equal. So now multiply the arguments. 9 times 8 equals 72. So you have log 72 equals log x. Just as we stated before in the previous example, the equality property of logarithms states when the bases of two logarithms are equal, the arguments are also equal, if they are equal to one another. So eliminate the logarithms, and you are left with 72 equals x. That is the solution for this. Now let's move on to the quotient property. You have actually seen the quotient property in action already. I just did not say it was the quotient property. The quotient property states that when one logarithm is subtracted from another, you divide the arguments. So, let's say you have a logarithm, argument 5 minus the logarithm, argument 7 equals logarithm, argument x. They are all the common logarithm, each of base 10. Since this logarithm is subtracting from this logarithm, you divide the arguments. You divide 5 by 7. 5 divided by 7 is 5/7. So you have log argument 5 over 7, or 5/7, equals logarithm argument x. Just as we have stated before, the equality property of logarithms says that if the logarithms with the bases, if two logarithms are equal to one another and the bases are the same, the arguments are also the same. Eliminate the logarithm expression and the base, and you have Well, class, it seems we have a few minutes left, so I figured I would give you an example for the power property. Say you have the logarithmic equation 3 log of argument x equals log of argument 343. As we stated before, the power property says that an exponent on an argument is also equal to the coefficient of the entire expression. It also means you can take the coefficient and turn it into the exponent. So you're going to take 3, move it to be the exponent on the argument. So you have logarithm x cubed equals logarithm argument 343. The equality property of logarithms says if the bases are equal and the logarithms are equal to one another, eliminate the logarithms, and you are left with the arguments. X cubed equals 343. How to solve it now? Take the cube root of each of these. The cube root of x cubed is x, and the cube root of 343 is 7. There it is. That's all you have to do. Just solve using the power property like you did each of the other properties. I'm Mrs. Hart. Thank you for coming to my class, and I hope to see you again. Goodbye.